So all of you have got a link, Google Drive link to download the materials. Did you got email about this programming exercises and those? I have shared a folder. Did you got that? Okay, okay. So you can go to that and download. I will tell you what to download. In the, yeah, yeah, yes, yes. Or you got maybe in the WhatsApp also, I think. The Drive, Google Drive link. You can check another.
Another room so they
Yes, sir, we be live streaming it.
Maybe server connection or else we'll bring all the students.
Yeah, that is that's
No? First full these labs. No?
So what they suggested is like we told that only earlier to them that you can bring all of
this one.
yeah. Yes, sir. Please don't disconnect LAN from these machines because these machines are added into the cluster. Then IPs will get changed. Yes, madam. I will tell you. You can keep it. Yes, sir. Yes, sir. Yes, you said that. It is like that. It's okay. Yes. Yes.
Now it's going to fix it.
Then I'll not go to much repetition like that. I'll start repeating. Only I will show that this diagram and another diagram.
So in both is what the
Yes.
some just like second year
I told them to make arrangement for right. Other rule is so here it will record right speak and there they kept one Bluetooth speaker.
I added all that which is connectable. In 60. If you want to demo, you can use this.
Yes.
60.
but have you tested it other than
Yes, yes. We tested with medical broadcasters and everything. Yes, yes. This distributing and we activated license. Because earlier we activated it that was when it was there, but this IP set it changed. Then we reactivated it.
इधर नहीं
Yeah, they said that. Sir, other class we can listen, we can hear. No? Check करो, check करो. audio test. Test. So yes, sir, we share along with them. So yes, yes, and it is YouTube live streaming also. Like it, sir. We'll start. So good afternoon to all. Can you hear me? Very well. Okay. So they are connecting with this microphone speaker. They told they will keep that. Bluetooth speaker. Okay. So I think in the morning session, sir has given a brief introduction to Aneka Cloud Application Platform. So it's a .NET based cloud where you can able to set up the cloud using this LAN connected machines. So and the users can develop the cloud applications using three different types of APIs: task, thread, and MapReduce. And Aneka provides a software development kit, and that using that kit you can able to develop the application. So it's basically using a .NET runtime environment. So now here, when you consider like how Aneka can be set up, so Aneka can be set up using either the LAN connected machines, okay, or maybe if you have a server, then you can use that server to create a virtual machines, and then you can set up the Aneka. So now coming to here, so this is where you are setting up the Aneka. So in our SGU cluster, like Aneka cluster, so we have used all the machines in this lab to set up Aneka cloud. So these all machines are LAN connected, and these machines are assigned with the static IP, and we have used the highest privileged user credentials like admin user and admin password, because so when we install Aneka on top of this LAN connected machines, so Aneka basically Aneka management studio or Aneka main, the kernel of Aneka requires the to access all the services from individual machines. So that's why like we require admin and these privileges. So now coming to here, this is an SU setup, Sanjay Ghodawat University setup. Like you have Aneka master, and these are the workers. So now here there is a machine inside that cabin. So that is like where we installed Aneka. So in that there is Aneka Management Studio. Okay. So I will give you a brief overview on that Aneka Management Studio, and all these machines are added into that cluster. So we have taken all the machines and we added it to the cluster. So like here you can see that 192.70.8.1. So but even the IPs have changed now. It is like 10.12.2.1. So upon like that. Sir? Oh, these people told that they shared the Zoom link to all of you. I think there you can see it. Yes, yes. I in that folder I have added this PPT also as well. So I will share you. I will tell you about all the resources, whatever I shared to you. So now here, let me take the Aneka Management Studio into for the demo now. So what is Aneka Management Studio? So basically, like when you install Aneka,
Here, this is speaker. Also, then they can listen. This is required where they can't listen.
so now Aneka, if you want to try out, you can go to manjarasoft.com and in the download section where you can download the Aneka software. And once you download the Aneka software, it is a Microsoft installer like a .msi, and you can install in any one of the system. Like how do you install your Microsoft installer like applications? And then once you install Aneka in any one of the machine, then you should see license limit. And somebody is accessing it. It's social. So once you install the Aneka, then it will create in the C folder Manjarasoft. So in that you see these many files are created. Okay, when you install the installer. Okay. So now what happens is like in this folder, so you see there is documents are like tell you about how to install Aneka. So there is an installation guide here. So it will tell you step by step like how to create a cluster, how to add a machine, how to delete a machine into the cluster. So all things are given in this installation guide. And then you have the other guides like task model, thread model, and map reduce model. So these manual will tell you how to develop your application, your own application. Okay, like so for example, you want to develop some image processing application using the task model. Then I will show you some demo. So from that you will get to know. So those manuals are given in this folder. And there is a dynamic provisioning folder. So this guide will tell you about like how to set up hybrid cloud using Aneka. So these are like a set of manuals. Yes, yeah, copy invitation. So shall I put it in Gmail, your Gmail, madam?
Yeah.
Get text file here. You already shared this, right?
Yeah, yeah, yeah.
Right.
Yes.
Yes.
Okay.
We already have access. Okay.
Okay. This is one meeting ID and then this is the password. So they can open it from there.
Save and video upload.
Yeah.
Save and upload the file.
In the Google Drive.
Yeah. All already sent Google Drive.
Yeah, yeah,
Yeah,
I
yeah,
said-
yes.
Yeah, just to upload the link there.
Yeah.
This is my my. I think just a minute. Yeah, that is possible. That is also. Yeah, I should. How they can get it. They can get it.
I will write down and write on the board.
Why still you was showing me license? It's a connection. Yes, sir. I will be free, but one we are doing only one connection.
Check with any other.
I will close and reconnect one more time. License limit 60 days. I don't have any connection. This is single connection to connect that machine. I will take minutes. Yes, sir.
That one there.
Yes, yes, I will take that. I'll take the super. We need a slide. Yes, sir. So now, so we have added all these machines to the cluster. You can see that there are these are the list of machines added into the Aneka cluster. Okay. So as I said that when you install Aneka, so it has list of folders. So you have a set of examples, set of installation guide, everything it will come in a C drive. Okay. So this is like where this is the Aneka management studio, where this management studio is used to set up the cloud. So we added all these machines from this lab into the cluster. And talking to the sir has explained about this architecture of the Aneka. So Aneka is a master and slave architecture, or master or worker architecture. So there is a master who will take the jobs from the end user and he will schedule in the worker nodes. So his responsibility is to supervise the task whichever is submitted to the end user. And the worker is an executor who will try to process the job whatever the master has given. Okay, so it's a kind of master slave architecture. So now coming to in the Aneka architecture, so master and worker, we call them as a container. We call them as a container. So there is a master container and there is a worker container. So in this scenario, like we have to create master container and the worker container. So master is an endpoint address to the end user, whoever submit the workload, so it will go to the master. Okay, something like I will show you here in the containers, as I said. So here containers, so you have, these are the list of workers and you can see there is a master here. So the master address is something like 51, 10.12.2.51. So that is there. The machine is there. That master machine is located there. Okay, and these machines are the worker machines. Okay, so while before going to setting up this worker master, so let me go through here. Like here you can see that this is the Aneka Management Studio, and here where you can able to set up the infrastructure. As I said that you are going to add a machines to the cluster. So now here like you need to add a machine, like you want to add a machine into the cluster. This is how you are doing it. So you need to put IP address here of that particular machine which you are going to add into the cluster, and then you need to add these access credentials, so machine credentials, because since it's a distributed system and you send a workload and that executes in a distributed manner, so you need the control, the full-fledged permissions from the individual machines, because you are running or you are stealing the CPU power of those machines. So this is the admin privileges as you need to enter. So this is how we are going to add a machine into the cluster. So we have added these machines into the cluster. So we'll not add those machines. Now here, so here then next step is to install the container. So container could be a master container, container could be a worker container. Okay. So now coming to here, master container. So master containers has some list of services. So what are the list of services is that, like sir has explained you about that Aneka architecture. In that there are foundation services, application services, and the other underlying services. So master will have information about all the worker nodes, like how much CPU that worker machine has, how many number of cores the machine has, and how much the speed of the CPU. So because the master should able to assign a workload to all of them, we should have the information about all the worker nodes. So now, and also master is also called as a scheduler. And what is a scheduler? Normally, what scheduler does? Who will schedule the jobs? So scheduling could be in different manner, like first in, first out, or last in, first out, or maybe round robin scheduling, or maybe suppose, for example, you want to schedule based on the past priority scheduling, past based scheduling, or you give the deadlines and then it will schedule based on the deadline, right? So there are different approaches of scheduling, and Aneka provides you an extensive feature where you can develop such algorithms even, okay, where you can schedule this workload to the different worker nodes. Okay, so but in terms of worker has only limited services where he can listen to the master, and if that workload and the data comes in, then he will take that workload logic and what is the data coming in, he executes and sends back result to the master, and master will collect all those results together and he will map the output to the end user. So this is the overall architecture of the Aneka setup. Now the question is how do you develop how the end user will use this Aneka setup? So as sir in the morning session explained about 3 APIs. One is task programming, thread programming, and the other one is map reduce programming. So task programming is say for example, there is an image processing application. You want to tell the application. So I will tell you about task programming model with an example. Okay. So now let us see how this task programming model works. So now, as I said you, whenever end user submits the workload, so he will submit to the master API. So master is running at the IP address 12.10.2.51. Okay, so master is running in that address. So now Aneka has a set of some built-in examples where you can try it out. Okay, so out of those examples, I will take one example which is image processing, that is called as convolution. Okay. So here, as I said, you have some list of built-in examples Aneka has. So in the example folder, so you have a task model. So in that task model, so you have three different types of examples, Maya render and Coiroy. So these are also like Maya render also is kind of an application where it is used for like designing these models, 3D models of the particular object. Okay, so I will take convolution, which is image processing application. So I will open this application. I will tell you, don't worry. In the Google Drive, I have shared this application where you can also run and you can submit the workload to the cluster. Okay, so here now we want to in image processing, basically you have different types of algorithms you can use, like image blur. You need to identify, like you want to blur the image, or you want to convert from black to white, and you want something like edge detection, and you want to convert the emboss, or like you want to convert the original image to emboss image. Basically, I think you know about embossing of the coins. So you have a coin, and then if you put a paper on top of that and then put a, like draw with using the pencil, then you will get a 3D image, or like a 3D embossed image of the particular coin. So like you want to get an embossing of those images, and these are like a compute intensive images, like a compute intensive tasks or jobs. So instead of running that whole job in a single system, which takes a long time, so what you can do is you can take that image, submit to the Aneka. Aneka will distribute that workload entirely to different worker nodes, collect that output, and you will get the embossed image in a few seconds or few milliseconds. Okay, so let us see that. So I will upload one image, something like not good image. Something let me just check our VC image. So now what I will do is I will take the VC image here. Okay. So now I want to convert this image into an embossed image. So basically what happens is, so this is my end user application. Convolution is my end user application. So now I want to submit this application to the Aneka cloud. So for that you have to say that where is your Aneka master, because you have to send a workload to the Aneka master. So here instead of like localhost, you have to give the IP of your master. So master IP address is 12.10.2.51, and it's running at 4900, because the entirely Aneka kernel architecture is message based, TCP message based architecture. So each service, like say for example, you have two containers, I said, master container, worker container. So these will run on a particular TCP port numbers. Services are running at particular port numbers. Okay, so now master is running at 12.10.2.51 and 9090 is a port number. So now let me say, okay, I will submit this here, and I say okay. And then what kind of image processing algorithm you want to run? So you can say that you want to run an emboss. So I just say that emboss. I think there is a problem in the image. Take some more image. Just let me try. So there is a problem with sending the workload to that machine. Oh, right. Yes. So let me take again the PC image itself, so it will be easier to understand. Yeah. So now, when you run, what is happening actually here is, so you've given a image of certain pixel, say 100 pixel by 100 pixel, and you need to tell that yeah, because Aneka is a distributed where the processing is the image processing happen in a distributed way. So you have to slice the images. So entire 100 by 100 pixel image is divided into something like you have to set the slice number, like 2 pixel by 2 pixel as a one slice. So you can view that the slicing here. You can see here I have given the slice dimension as 492 by 577. So meaning that so entire image divided into and one slice is 499 by 577. So it is divided into how many number of slices it has been done? So it has been done around 30 slices. And these 30 slices, okay, are submitted to the master. So master, what he is doing? So now he is distributing that workload to the different workers. Okay. So what are who are the, you can see here. So total 30 here, and you can see that. So whole 30s are divided something like here, and you can see here 6, 6, 6, and 6. 1, 2, 3, 4, 5. And still again there is something is going on here. So it is entirely the Aneka, the whole entire workload is distributed among, and the worker performs that job, and he will send back the result to the master, and master will display that result here. So what happens if you run on a single standalone machine? So it takes more time because it's running on the single machine, and it uses what however it has. If it has a 4 cores, then it utilizes. And if you do parallelization to utilize that 4 cores, that is okay. But even still, it requires like more number of cores. So this will be done in a few seconds, a few milliseconds. This job is done. And now the same thing you can write your own kind of scheduling algorithm, how to schedule that. So either cost based, you can give the deadline for this image to do. So in that time, what Aneka does is it will see how many workers are available. Okay, if you give deadline, if the jobs are not possible, then it will connect to the different cloud. So you have to configure that cloud, and then those jobs are migrated there, and then perform the operation, and then it will come back. So like it's a kind of hybrid cloud architecture. Okay. Yes, sir. I can say that. So sir wants to show your photo on the screen to get an emboss from your original image. So you can see here the slice dimension here, like you can see 112 by 112. So this is a slice dimension very real. So this whole image is divided like 112 by 112, like one slice is that dimension, and then it is executing. Maybe some of you can see in your CPU usage cycles. Maybe in some machines, something like these are the machines added to the cluster. You can see the CPU hype in the CPU cycle. And here also in Aneka, in your management studio, so this is one image which sir has taken. So you can apply any algorithm here. Image processing applies like sharpening, embossing. Embossing we just done, like mean removal, smooth. So these are image processing algorithms. And if you want, you can change the slice dimension here. So you can change how much slice dimension you want to give. So now here again. So now here, now we will convert this into again, we will take an emboss of this image. So now you can see that. So what is happening? So when you run this application, so that slice are going back to the different workers are coming back. That's why you can see that some of the worker have given faster processing, have done the faster processing and submitted to the master, and some are still in delay, right? And when you see this, the workflow here, like where it is submitted, yeah. So now you can see that there is a 90 Aneka ABDQ1 Aneka Lab B12 107. So these are the machines from this cluster. Somewhere I think. So now let us see. So let us see. Show the cloud. So you can see that. So this is the image, and you can see the embossed image here. Here where I am like, giving the session here, and here Satish sir is there, like for like maybe first 3 rows you can see that here.
Hello.
So you can see that there is still some jobs are like processing at some node. Maybe that node is busy and it's not giving the results. And now it is completed. So now you can see the emboss of that picture converted into a 3D emboss of that image. So if you see the what is the entire, how much CPU consumed by this application, how much time taken by the application to process, and where in which node the tasks have been run. So that all like statistics you can get from the our cloud management studio. So once you go here in the cloud management studio, so there is a set of tools where you can visualize all of the information. So this is a so now you can see here that will tell you your whole cloud infrastructure, what is the size of your cloud infrastructure. So at the top you can see there is like something like number of CPUs 48, because we added around how many nodes, 8 nodes. So 8 nodes, I think it is a 6 core machine. So 8 into 6 is 48 like, and you can see that total the CPU number of power, maximum CPU power available is 144 gigahertz, and then how much CPU currently is in use, and how much is available and how much is used. So you can see, yes, and here like these are the two bars. So one bar says about availability, the another bar says about the usage. So when you run your task or when you run your convolution or any kind of workload, then this the usage line goes up and the availability line will come down. Yes. Now let us see that like how it, so when I run this, you can see that there is a fluctuations in the CPU cycles. It's not that much huge, but you can see that it is slight change because your cluster is too huge and it doesn't take much CPU power to to process that task. So you can see there is small change on that side. You can see that. So that part. And so this all information your master will have, so that he can able to freely he can submit the jobs to the worker node. So this entire application is based on task programming model. So what is a task? Task is that you have some logic and you give the data. So here the logic is to convert from original image, one slice of the image from original image into a embossing image. So that is one task or one job. And what is the input? Input is your slice. So it will be given to the particular worker, and he will take that computation logic and he will take the data unit and he will do processing. So task as a task, Aneka provides task programming model. So using that API, task programming API, you can develop such kind of task based applications like image processing application, or like suppose for example you want to run a 10,000 bag of tasks. So bag of tasks means each task will do some operation, some like addition of 2 numbers, and you want to do addition of around 10 lakh numbers. So those are designed using this task programming model. So
कर सकते हो बच्चे, अभी क्या है बोलते क्या फिर नॉइस हो जाएगा सबका।
So now here is 1 by 12 pixel of one slice is one task. Okay. So these are like built-in example, but in hand you can write your own application using Aneka SDK, Aneka software development kit. But like we will go soon into that how you can develop your own application. So using Visual Studio and SDK. So you can also try it out. Yes. Yeah. So this is an image from the other room where so now this image is converted into a different way. You can apply different. So emboss could be one best example because you can able to realize that what is happening. So you can see that students like sitting in different classroom. So this application can be in a broad category. Suppose, for example, you want to detect machines aligned in a lab are properly aligned or not. So it's a kind of image processing where you can detect some like to take the attendance. Say for example, 20 students are sitting, and you can design one YOLO task to detect the number of persons in the classroom, and we can tell that okay 100% attendance or something. So any kind of image processing can be, which is huge compute intensive, can be developed using this Aneka task programming model. For example, one sir could have told you like about drone based monitoring, where drone will capture the streaming images, like videos are streamed in a streaming manner, and those images can be processed, sent to the Aneka master, and Aneka master kind of do the processing and detect something like humans in the something like flood area you want to detect. So these kind of several applications can be try to design in using Aneka. So why it is so necessary? Because something like you want to monitor the persons in a flood affected area, which is like the latency is you want like more less latency. So you want a immediate response for that. And here when you submit to Aneka worker can scale it up to do it faster, and it can scale down whenever it is not required.
Yeah. Go to ask the yeah.
So this same application can be designed using programming also. So to do that, the end user required a Visual Studio. Okay, so because he has to develop, and it should be like in a .NET environment, Visual Studio .NET environment, and you require a Aneka SDK, software development kit, and then one configuration file. So what is that configuration file? In that configuration file, there is a master address where you are going to submit your jobs. So I will just try to show you one example, simple example of task programming model. Now what I will show you one example of thread programming model from this, how you can able to design your own thread based application using Aneka thread API. So now
Yeah, I'm looking.
So here in the SDK, so I told you that when you install Aneka, so you will get a list of folders. So in the list of folders, there is also one folder which is called as SDK, Software Development Kit. And if you open that software development kit, so these are the software development or APIs. So this is for thread API, task API, and also so other one is like MapReduce API. And so when you develop your application, so you need a Visual Studio. So now here, so this is a program using thread API, and where I will write Aneka thread, which will be submitted to the master. As sir also in the morning session, maybe they have explained about this Aneka is a distributed thread. So you have a C# .NET threads, Java threads like that. So, but this is an Aneka has a Aneka distributed thread programming model. So once you submit to the Aneka, so Aneka will try to distribute that threads into different machines and collect the output from those machines and then try to display the output here. Okay. I think maybe I will different way. I'll explain the process. So now this is the sample code. So this is the sample code, Aneka thread API. So now so you can see here, these are the APIs or the runtime libraries which are added. So using Aneka, so Aneka threading and Aneka.entity. So these are Aneka related thread API, like the software development kit libraries, .NET libraries which you need to add. And then when you come to the main, this is the main program here. So here you are creating an Aneka thread application. So Aneka has Aneka thread and thread manager. So thread manager, basically when you submit distributed threads, so you have to collect the results from those, sync them, join together, and you have to collect the output. So thread manager will do that job, and you have Aneka the thread. So this is the where you just initialize or create Aneka application with the application name. And then in the next step is you have to say where is your Aneka this configuration file. So what is this configuration file? Configuration file tells that where is Aneka master. So if you see the Aneka configuration file here, so this is the Aneka configuration file. So here you can provide your QoS. So what could be your QoS, quality of service parameters? Suppose for example you have some time constraint, cost constraint when you are submitting your application, or if that task fails, then what to do? So either rerun that or something like retry. So those kind of, and then you can give this your master API. So master API is something like in our case is 12.10.2.99. So this is our master address where we are submitting the workload, the thread application to that master. And then these are the user credentials. So you need not to, if you have, you can give, otherwise like you can leave it blank, or you can give the here to submit to that master. So the credentials my 1 2 3 4 5 6 the password, and here the username is admin. Okay, so this is the configuration file. So in your program, so you have to give where is your configuration residing, where is your configuration file present. So what is the path of your configuration file? So in my case, the path of the configuration file is this one. So I will save it. This is my path of my configuration file. And next step is you have to create the application, that is Aneka application. Okay. So here Aneka application, and then you have to map that configuration. So what is the configuration? Configuration is that where your master resides. So you have to tell that Aneka to your application. And next step is where you are creating your application. So I am just creating one function called hello world, meaning that when you run this program, that thread should say hello, or something like hello world, or whatever functions you want to do. Something like, say for example, here I created a class object called HW, And if you see the class here, hello world with a simple thread with a here hello world class, and then it says hello Aneka. Okay, so now this is one simple thread, and then next is about so here if you say that Aneka, so you created Aneka thread here. So this is how you create Aneka thread. So Aneka thread belongs to this application. So Aneka thread in an object with Aneka thread, and where what to display, what to do that function. Function is to display hello world. So here hello world dot print is the method. So it will call this method. Okay. So now and then and finally you have to run that thread. So your thread has a many functions: start, stop, right? And thread dot join. Right? Aneka distributed Aneka thread also has all these operations. And then now here, so start the thread, meaning that the thread is submitted to the master, and now you have to collect the output. You have to join that thread. So the function is that Aneka thread dot join, and then finally you collect your output here with the target. And then you can print what that said, which node it is submitted. So you can see here, you can print all of them. So here completion time. So which node it is submitted, Aneka.node ID. So it will give in which machine it has been executed, and what is the completion time, and what is submission time. So all this like Aneka has set up methods where you can invoke that methods to display all the parameters. Yeah, this is how you create your Aneka thread application. Activated now. Morning, I am at work. Any systems are like just for you. Yes. Let me just check. Let me download from there. My Visual Studio license, it is expired, it's saying. You tested in the morning. Yes, sir. Or else I will copy and paste this example there. So can you able to see this at least program? Yes. And then run there. Yes. Yeah. So now, what I'm doing is I have you also have the Visual Studio. So I will tell you later to run your code. So we have Visual Studio on that machine because my laptop Visual Studio is not working. So due to some license expiry it is showing. Okay. So now I will run the code which I just explained to you from that machine. Okay. So I have Visual Studio. I have opened the code here, and now here, but I have to update this part of this configuration file. So part of the configuration file is this one. So now you can see that. So Aneka has given me an output. When I ran this code, it's compiled and it is sent. So what is the output it is giving is, so it's given me. So the output is like this. So it is saying hello Aneka. That thread is saying hello Aneka, and then the value. That's just simple any. Which is, you can display any string, and then this is the completion time. So you can see this is the completion time, and in which node it is running. So Aneka lab 019090. So Aneka lab 1 should be that machine. So maybe it has, the thread has executed in this machine, the first machine. Okay. So now this is just a simple thread. But now, since this is a simple thread, you will not be able to see the difference. The submission time and completion time is very short. Okay. So similarly, you can run now 50 threads or 100 threads. Okay. So before trying to that, maybe I shared you the code. I have a Visual Studio. Later, in the last half an hour, we will do the experiments. Like you can also submit the code and you can see the results. Okay. So now let us do the similar experiment, but with the 50 threads. So you can see when I run the 50 threads, then the threads may be executed on different machines, and even the submission and completion time could be different. And as of, if you are doing a research on scheduling, you can schedule the threads on different machines, and you can assign the cost, the time, and then you can reschedule. So those things you can apply. Okay. So, but to do this, it is not as simple as doing or running this program. You should have some kind of knowledge on the parallel computing, like thread programming model, web sockets, TCP connect, like TCP communication, and main importantly the parallel architectures and the CPU architectures, and then SIMD, MIMD. So these concepts has to be in your mind. So for that, sir has shown you one book, that is Mastering in Cloud Computing. So in that, So the entire information is given. Like basically, the first chapter is about introduction. Second chapter is about what is the parallel programming, CPU architectures, x86 and different, and then MIMD, SIMD architectures, and then next chapter talks about virtualization, and next is about thread programming model, task programming model, map reduce programming model. So all the detail given in the textbook how exactly this will work. Now let us run the 50 thread program. So now here what I am doing is the same program, but I'm trying to run 5 threads. Okay, so you can see from the code here. So here the Aneka thread dot start. So I am running for 5 threads, putting in a loop. Okay, and I want those threads where they are executed and what is their completion time. Okay, so here you can display here. So here you can see the submission time, node ID, and then again the completion time. So these are given here. So now this is a 5 threads. So you can go for 50 threads or 100 threads based on the computing capacity of your cluster. You can try to run them. So let me run this. But here I think I have to change the configuration file path again here in this program. Okay, so the configuration file path is
कंपनीत कसा काढला फायनान्स किती आहे
so run that, and now you can see that. So now you can see that. So this is Aneka thread 1, 2, 3, 4, 5, and running on different nodes. Basically, it is running on a single node. Why? Because threads are like only just a simple 5 threads. So it is submitting to the single machine. If we add 100, 200, 1,000 threads, then it will distribute on different workloads at different nodes. Okay. So now what you can do is like I shared you a Google Drive, right? So you have a Google Drive with you. Okay. So now can you download this example folder? So you download this example folder. Is it giving any error to download? Anybody have tried? Are you can able to download it from my Google Drive shared link? Oh, okay. So example folder you download it. Okay. Then I will tell you to run this task model. This example, that's convolution example. You can upload your image and then submit to the master. Then you see if all people submit at one time, it's a huge workload submitting to the Aneka master. So that you can able to see it. But the question is like, how do we make it faster? Okay, how do we make it faster? How to scale it? Because cloud is means like you should have a scalability feature. So you can tell Aneka that if you require more workers, then you have to bring from somebody else. If this cluster is full, then you have to provision from some other location. So where is that other location? Either could be AWS cloud, or either could be Microsoft Azure cloud, or either could be any of the other third-party cloud provider. So there, for that you have to configure in Aneka. So because it suddenly doesn't know which AWS region it has to go. It doesn't know where, in which location of the Amazon data center it has to go. What are the credentials to access that particular data center? So it doesn't know. So you have to configure everything in Aneka and tell that. So whenever there is a more resources are required, so you can able to spin from the AWS. So that is what we call it as a hybrid cloud architecture. So you have private cloud setup here, and then there is a public cloud, and integration of both private and public is the hybrid cloud implementation. So you can, if you are doing a research, especially the faculties, like if you are doing a research on scheduling, then you can extend Aneka scheduler. So master has different scheduling algorithms, time constraint algorithm, cost constraint algorithm, or maybe some kind of professor was telling about something like Mandi algorithm. So Mandi means like you go to vegetable market and you bargain and buy the vegetables. Like that, in a cloud market, you can bargain and buy the things and then execute your jobs. Right? So you can design one orchestrator, cloud orchestrator or scheduler who will bargain and get the resources. Right? So these kind of things you can do it, but it is in 3 hours. We can't teach that, like, you know, how to write your own algorithm and those things. We can show you a simple algorithms. Yes. Yes, I will show you that. So now, good question. So sir is asking about what is the default scheduler now the Aneka is using. So when I go to this Aneka Management Studio, yes, yes, please. So now the question is like, now which algorithm currently Aneka is using to schedule these threads, right? So you can set based on your requirement. So, but I will show you what it is using currently now. So now here you have Aneka cluster, and now you have your master here. Okay. So actually I did not told about how to configure master and how to configure the worker. So configuring master is configuring a scheduler. So to how to configure master, how to set up Aneka, how to set up worker. So in Manjulasoft website, in download section, there are list of videos where you can able to try in your laptop how to set up master, how to set up worker, and those things. But now here I will show you which algorithm it is using, or which algorithm I configured it now, scheduling algorithm. So now you can see here. So can it be visible, this part? So here you have, there is a task scheduler, thread scheduler, map reduce scheduler. Okay, these are the 3 schedulers. So each API has its own scheduler. Task scheduler, which will help you to schedule the task submitted to the master to the different worker nodes. Okay, now sir's question is, how does these threads are scheduled? So here when I go to thread scheduler, and you can see here algorithm which it is using. By default it uses FIFO. So first in first out. So when I expand it, so you can see here there are list of already built-in algorithms. So clock priority algorithm, fixed priority algorithm, and there are other data aware scheduling algorithm. I think time cost optimization algorithm. So that you can develop that algorithm and you can import into this scheduler to run basically. But the catch is here. So out of this, few algorithms are static algorithms and few are like dynamic scheduling algorithms. What is static scheduling and dynamic scheduling algorithms? So static scheduling algorithms doesn't have any constraints. So you don't give any deadlines for the task to run. You don't give any cost constraints. You don't give any of the particular QoS constraints, right? So you say that, okay, run my jobs and give me the results. At whatever time you can take the time. So statically running. So what is that dynamic or dynamic provisioning algorithms or dynamic scheduling algorithms? So you give the constraints, like you give the cost, you give the time constraint, you give deadline. So you say that I want all 5 threads to be executed in 30 seconds or 10 seconds. So then scheduler should be awakened to test either that 5 threads can be executed 30 seconds locally. If not, get from somewhere else. Right? So that is how like this dynamic provisioning algorithms and static algorithms will work. So you can develop your own algorithms if necessary. Like here you can see there is a customized like where you can develop your own scheduling algorithm. So that is same for the task and that is same for the thread. So but MapReduce has a only single scheduler. That is like it uses the same architecture like Hadoop architecture. A yarn scheduler, like similar concept here also there is only one scheduler. So but the main difference is here like out of 20 nodes, some nodes you can choose them as a storage nodes and the other nodes as a compute nodes. Same like in a Hadoop, you have a data nodes and the storage node, like similar approach. And you should have a data that is distributed and stored in a different nodes and easily available to the worker nodes for computation. Yes. A good question. Yes. So for that, you have to write your own logic. So what task has dependent on what? So at the end, because Aneka is giving you the API. So either task API, you're talking about like say workflow scheduling. So you have a set of workflows to be executed on different nodes and each has a dependency. So for that, you have to write your own front-end logic. So the logic, the schedule, what the master does is it only takes what the user given the logic. So it doesn't look what is there inside. So it sees like, okay, this is the logic to be executed and these are dependent and these are independent. So it will categorize based on your logic. And then it will try to submit. And then it modulates saying that, okay, this task output is dependent on this. Then so as soon as the output comes, then it will generate, it will try to run the other task. So there is one article on this, how to schedule, do the workflow scheduling of task using Aneka. So there is one paper on that, like how this bag of task or the dependent task can be executed on the Aneka. So using some optimization algorithms. So that is, there is one paper you can have a look into that one. So this is how you configure the scheduler. And there is also one more thing like I told about. So Aneka should find some other cloud, right? So whenever you give the some constraint like cost constraint or maybe some the other kind of any constraint, QoS parameters. So you have to connect to the other cloud. So where to give that credentials to connect to the another cloud. So that is the property of dynamic provisioning here, resource provisioning. So here you have to mention which cloud it should connect. So if I open this, then here it shows like manage. And here you can select which cloud you want to connect, AWS, Azure. So right. And if I select here EC2 compatible pool and then give some name here, what is your cloud name? And then you have to add all the credentials to connect that cloud. What is the endpoint URL? What is the image ID to download and run your task? So all this you can able to give here in this. So did you download the applications, that example folder? So how many of you downloaded? Okay.
Just try to open it and open on .xml file. Then you show the master IP and password.
Yes.
Then will come around which of the application problem.
So we'll do one experiment. Those who have opened, raise your hand. Those who have downloaded. Okay. Yeah. So please, all of you see here. Like we will tell you how to run this.
Yeah. Open
So
studio. There is no.
yeah, we will run one image convolution first, and then we'll go to the code. So now there is a in example folder. There is one folder called as yeah. So go to task model. So you have one folder called task model, right? So in that you have image convolution, right? So in the image convolution, you go to just let me, I will open in my Google Drive here, so it will be easier. So here, this one, convolution.demo. This is one application. So now go to examples, go to task model, go to image convolution, and go to this convolution.model. Open this. So now you should be able to open this. If you ask for that, don't run or something, just make it like run anyway. Okay. Can you able to open this application? Nothing is there. Let me. So what we will do is, if you are unable to run that application, so I will put my aneka.exe file into your folder, in your shared folder, and then you try to double click and install it. So all examples will come in your machine. Okay. So can you also able to download the code also? Okay. So do you have Visual Studio? Please check it. Do you have Visual Studio? Okay. So now I think first we will execute code and then we will go to that application, because otherwise it will consume the time. Okay. So now I think you have this example folder, and in that you have an examples folder again, right? So in that, just open this simple thread program. Open the simple thread program, double click, and then again open the folder and go to the solution, and then right click on this and open with Visual Studio. Yes. Example, and then go to simple thread program. This one, simple thread, and then open that solution in Visual Studio. Solution file .sln, right click this and then say open with Visual Studio 2010 or something like. So how many of you can able to open this? Can you able to open? Are you able to open? Okay. No, we have to. Ready? Okay, fine. So can you change this program to run for 50 minutes? So now. We already. And then you can trust. So those who are like here, can you open your CPU monitoring tab like in Task Manager? To open and click ready. So what we have to do is like now here one, so here start, then second here, third there, there third, fourth, and five. So you make it to run like 100 threads each. Okay, and you open like you open Task Manager and you see the spike in CPU cycles. So can you change that simple credit to run for 100 threads? Yeah. Okay, that's nice. So now, so same thing like could you also run the for 1000 threads? Yeah, please run it for 1000 threads. So now 1000 here, 1000 there, 1000 here means like 5000 threads are executed submitted to the Aneka now. So meaning here. So now you can see here, still there is no much spike here. So does anybody? And it's all special. How much load is used and how much load is available. Yeah, this is what we do. Just use the whole lot. Yeah, whole machines. Yes. Yeah, that's right. But usual machines. Yes.
Hello. 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 Hello.
So if they are
Hi. I'm coming to them. Sir, I'm like, my family is coming up. So I'm okay. Sir. What time should I come? 5 and year 6. So can all of you try to run 1000 threads at a time? You say 1 to 10 is somebody. Let us do that. Change the problem counter. So all of you ready? So change that column to 1000. Array of 1000. Change that to array of 1000. Two follows also 1000. So done. Code changes are done. So let's submit. So others can open your CPU cycles and see like where the tasks are coming to your system.
Because in multiple we don't want to now of course
So let us submit it. Please submit a 1,000 task. Make a master print. Let us see that you are ready. So all submit. Submit now. Yes. Just one second. It is submitted. How many of you have submitted?
Yes,
Only one. What about others? Okay. So now the time is up. We have more questions. Like we showed about task programming and also tech programming. And you can also try to configure or install in your machine. You can download from Microsoft website and try. There are some list of videos and some the website also list of research articles on the data of their learning. For that. Sir, 70 kilos submitted. Their task is and it's spread task.
Sir, sir is calling.